ተማሪዎች እንዴት ናችሁ? ባለፈው ክላሳችን በሰፊ ሁኔታ ስለ ሞለኪውላር ጂኦሜትሪ አይተናል። እናንተም እዛ ላይ ትኩረት አድርጋችሁ ስትከታተሉኝ እንደነበር ምንም ጥርጥር የለኝም። ስለዚህ ወደ ዛሬው ክላስ እንቀጥላለን ማለት ነው። እርግጠኛ ነኝ ዝግጁ ናችሁ? Okay, let's continue today's lesson. In today's lesson starts from intermolecular forces in covalent compounds. You know intermolecular force. Remember, there are two types of electrostatic forces. One is intramolecular forces. The other one is intermolecular forces. Intramolecular force affect the chemical properties of the species, like ionic bond, covalent bond, and metallic bonds. The other one is intermolecular forces. Intermolecular forces affect the physical properties of the species. Intermolecular force is force of attraction between species. Therefore, this is intermolecular. Intermolecular means what? Force of attraction between species is known as intermolecular forces. Therefore, intermolecular forces in covalent compounds. Intermolecular forces, force of attraction between atoms or between molecules. In the case of intra, not between, within a molecule, within a species. Therefore, this is force of attraction between atoms or between molecules affect the physical properties of the species. Remember, intra, this is intramolecular force affect the chemical properties of the species. Ionic bond, covalent bond, and metallic bonds are chemical bonds. This is not chemical bonds. This is affect the physical properties of the species. Therefore, this one is not chemical bonds because not affect the chemical properties of the species. This one is relatively weak. In the case of intramolecular force like ionic, covalent, and metallic is strong. This one is weak bonds. The common intermolecular forces are London force or dispersion forces, dipole-dipole forces, and hydrogen bonding. This is a three in inter, not intra. The three intermolecular forces. Therefore, London force or dispersion force, dipole-dipole force, and hydrogen bondings are not a chemical bonds. First, what mean by a London force? What mean by a London force? London force is force of attraction between what types of molecules? Between two non-polar molecules. You know polar and non-polar. Therefore, force of attraction between non-polar molecule is called London force. London force is a weak because it is under intermolecular force. For example, carbon dioxide. Carbon dioxides are non-polar. The force of attraction, carbon dioxide with another carbon dioxide, is non-polar bond. Another example, Cl2. Cl2 is chlorine. Cl2 with Cl2. H2 with H2. Methane with methane. You know methane, it is an alkane. By the way, alkane, alkene, alkyne. You know in grade 9, in grade 10. Alkane, alkene, alkynes are non-polar. Therefore, force of attraction between alkane molecules, between alkene molecules, between alkyne molecules are known as London force. Therefore, London force is force of attraction between what types of molecule? Between non-polar molecules. The other one is dipole-dipole forces. Dipole-dipole is force of attraction between polar molecules. Between polar molecules. You know polar. For example, HCl. HCl. HCl is polar molecule. Another HCl, it is polar. Force of attraction, HCl with HCl. Look, this one for dipole-dipole force of attraction. HCl. HCl is one molecule. Again another HCl. HCl. This is another molecule. Now, as compared to hydrogen and chlorine, Which one is the most electronegative element? Chlorine. Therefore, chlorine is partially negative, hydrogen is partially positive. Again here, hydrogen is partially positive, chlorine is partially negative. You know HCl is polar. Therefore, this is polar. This one again polar. Both are polar. This is one molecule. This is another molecule. Force of attraction between these two molecules. Student, please note this one. This is intra. This is again intra. Now, this is intermolecular forces, this one. The partially negative end of one molecule attached to the partially positive end of another molecule. Therefore, this one is intermolecular forces. This intermolecular force is dipole forces. This one is dipole forces. Simply, force of attraction between two polar molecules. The partially negative end of the chlorine atom attached to the partially positive end of hydrogen atom. Therefore, this is intermolecular force. This intermolecular force is dipole forces. The third one is hydrogen bonding. Hydrogen bonding is the special dipole forces. The special dipole forces. For example, in the case of London force, force of attraction between nonpolar molecules. In the case of dipole, force of attraction between polar molecules. Hydrogen bonding, again, it is force of attraction between two polar molecules. But this one is the special dipole force of attraction. Why is it special? Because hydrogen atom attached to the three most electronegative elements. What are the three most electronegative elements? Fluorine, oxygen, and nitrogen. Therefore, by intermolecular force, hydrogen atom attached with fluorine, attached with oxygen, attached with nitrogen, it forms hydrogen bonding. Therefore, hydrogen bondings are the special dipole forces. Look, one structure for hydrogen bonding. HF, another HF, again another HF. How many HF? 3 HF. Therefore, HF, one molecule. HF, another one molecule. HF, again another molecule, and so on. Hydrogen is partially positive, fluorine is partially negative. Again, hydrogen is partially positive, fluorine is partially negative. Hydrogen is partially positive, fluorine is partially negative. Now, HF is already polar. Why polar? Because there is polarity between HF. The bond is polar bond. The molecule is polar molecule. This is polar. Again, this one is polar. Again, this one is polar. Now, this is intermolecular force. This dot represented by intermolecular force. This dot represented by intermolecular force. Is it dipole? Yes. Why? Because the partially negative end of fluorine attached to the partially positive end of hydrogen atom. But is it special? Yes, special. Why special? Because hydrogen is attached to one of the three most electronegative elements. In this case, fluorine. Therefore, this bond is special. Because of that, this is hydrogen bonding. Why hydrogen bonding? It is force of attraction between polar molecule. This is again dipole. That's the special dipole. Why special? Because hydrogen atom is attached to one of the three most electronegative elements. That is fluorine. Again, this is also hydrogen bonding. Not only for HF. Another example, water. This is the structure of water. This is another water molecule. And so on. And so on. This is the structure of H2. You know water is V-shaped structures. Oxygen is partially negative. Hydrogen is partially positive. Hydrogen is partially positive. This hydrogen is partially positive, and so on. Now, there is force of attraction between the partially positive end with the partially negative end. Student, this is again special. Why special? Because hydrogen is attached to another, the three most electronegative element. That element is oxygen. In this case, fluorine. This is oxygen. Again, this is hydrogen bonding. Therefore, Water, it contains hydrogen bonding. Please, student, this is not hydrogen bonding. This is intra. This is covalent, because these bonds are formed by sharing of electrons. Again, these bonds are between partially positive with partial negative is what? Again, this is hydrogen bonding. But in the previous example is this one, HCl with HCl, one molecule, one molecule. This one is partially positive, partially negative, partially positive, partially negative. This is intermolecular. But this intermolecular is dipole-dipole, not hydrogen bonding. This is not hydrogen bonding because hydrogen is attached to chlorine. Chlorine is not the three most electronegative element. This is dipole-dipole, but not hydrogen bonding. This is hydrogen bonding. It is special. Again, this is hydrogen bonding special. Therefore, the three intermolecular forces are what? 1, London force. 2, dipole-dipole. 3 is what? 3 is hydrogen bonding. Hydrogen bondings are the special dipole-dipole forces. Look this table. Intermolecular force, hydrogen bonding, dipole-dipole, and London dispersion force. The strongest, which one is the strongest? Hydrogen bonding. The strongest, dipole-dipole, moderate. London dispersion force is the weakest. All are relatively weak, but hydrogen bondings are the strongest intermolecular force. Hydrogen bondings are the strongest intermolecular force. Polarity. Hydrogen bondings are polar. Dipole-dipole, again polar. London dispersion force, it is non-polar. This is simply the difference between the three intermolecular forces. Next, metallic bonding. Metallic bonding. Metallic bonding is the third types of intramolecular forces. Why 3? 1 is what? Ionic bonding. 2, covalent bonding. 3 is what? Metallic bonding. Metallic bondings are a chemical bonds. What is metallic bonding? Metallic bondings are the properties of metal, the properties of non-metal, or it is metals. Therefore, metallic bonding is formed by force of attraction between freely moving electrons and metallic nuclei. Nuclei means nucleus. Simply, metallic bonding, the force of attraction between freely moving electrons and the metallic nuclei. Freely moving electrons with the metallic nuclei, attraction can be formed. This attraction is known as metallic bonding. Metallic bonding is referred to as bonding in metal atoms. Referred to as bonding in metal atom is metallic bonding. The strength of metallic bonding depends on the number of contribution of electrons. Also the size of the atoms. The strength of metallic bonding depends on 1, the contribution of electrons. 2, it depends on the size. For example, sodium, magnesium, and aluminum. You know, sodium is group 1 element, sodium is metal. Magnesium is group 2 element, magnesium is metal. Aluminum is group 3 element, aluminum is metal. But which one is high melting point? Look, sodium, for the formation of bonding, contributes how many electrons? Only 1 electron. It contributes 1 electron. 1 sodium contributes 1 electron. Magnesium is group 2 element. Because of group 2 element, magnesium contributes 2 electron. Aluminum is group 3 element. Aluminum contributes 3 electron. 1 aluminum, it contributes 3 electron. 1 magnesium, 2 electron. 1 sodium, 1 electron. Which one is contributes more electron? Sodium, magnesium, or aluminum? Aluminum. Therefore, in strings, in boiling point, in melting point, aluminum greater than magnesium. Magnesium greater than sodium in melting point. Now, this strings depends on what? This strings depends on the number of contribution electrons. 1. The second one is depends on size. Let's take group 1 element. In group 1 element, lithium is group 1 element. Lithium, sodium, potassium, rubidium, cesium, francium, all are group 1 elements, all alkali metals. Lithium contributes how many electron? 1 electron. Sodium, 1 electron, all contributes 1 electron. The number of contribution of electron is the same. In this case, depends on size. Which one is the smaller the size? Is it lithium, sodium, potassium, or rubidium? Which one is the smaller the size? You know the periodic table properties. Lithium is the smaller the size. The smaller the size, the higher the melting point. Therefore, in melting point again, in melting points, lithium greater than sodium. Sodium is greater than potassium. Potassium is greater than rubidium, and so on. And so on. Now, for metallic strengths, in group 1, down a group, metallic strengths decrease. Metallic strengths decrease. But metallic properties increase. Student, metallic property and metallic strengths are not the same. Metallic strengths depends on number of contribution of electron and size. Metallic property means the characteristics of losing of electrons. The tendency, which one is easily losing of electrons. The higher the size, easily losing of its electrons. Now, as compared to lithium and sodium, which one is loses more electrons? Sodium. In metallic property, sodium greater than lithium. In metallic property, potassium is greater than sodium. But in strengths, lithium is greater than sodium. Simply down a group, metallic strengths decreases. Now, the strengths of metallic bonding depends on contribution of electrons and the size of the atoms. This is the examples of metallic bonding. The examples of metallic bondings are metals: sodium, potassium, lithium, cesium, magnesium, beryllium, calcium. All these elements are metals. Therefore, a good examples of metallic bondings are these elements. The other one is properties of metals. Students, you know the properties of ionic compound. You know the properties of covalent compound. This is the properties of metal. What is the properties of metal, especially physical properties? High degree of electrical conductivity. High degree of electrical conductivity. A high degree of thermal conductivity. Metals are conduct electricity. Why metals are conduct electricity, students? Why metals are conduct electricity? Please try this question. Okay, thank you. Metals are conduct electricity because of free electrons. Because of delocalized electrons. You know delocalized, you know free, which is mobile. Therefore, metals conduct electricity because of free electrons. It is luster or shine. Metals are shine. Most metals are silver color or gray in color. High density. Metals are high density, malleable and ductile. You know malleable like sheets, ductile like wires. This is the properties of metal. High melting and high boiling point, the characteristics or the properties of metals. Chemical bonding theories. The two modern chemical bonding theories are valence bond theory and molecular orbital theory, VBT and MOT. The first one is valence bond theory. This one explains bonding between two atoms caused by the overlap of half-filled atomic orbitals. The overlap of half-filled atomic orbitals. By the way, there are two types of overlap of atomic orbital, which is sigma and pi bonds. The three simple types of overlaps are, one SS, the other one SP, and the third one is PP. Look the first one, SS overlap. Before SS, PP, and SP, there are two types of overlaps. Two types of overlap. One is sigma. The other one is pi. Sigma is represented by this symbol. Pi is represented by this one. Sigma bond is formed by head-to-head overlap or end-to-end overlap. Pi bond is formed by parallel overlap. This one is by parallel overlap. This one is end-to-end overlap. End-to-end overlap. End-to-end overlap or head-to-head overlap. This one is parallel or sometimes known as lateral or side-to-side overlap. Therefore, sigma and pi bonds. Now, the three simple types of overlaps are, the first one is S overlap. SS overlap. Example, you know S, the shape of S? S is spherical in shape, this one. Another S is spherical in shape, this one. Therefore, this spherical contains one electron, another spherical contains one electron. Between these two produces this one. This is overlap. This overlap contains two electrons. This one is nucleus. This is nucleus. This is S. This one is S. This one is SS. This is nucleus. This one is nucleus. Therefore, the force of attraction or the overlap between S with S, S with S, SS overlap can be formed. This SS overlap is head-to-head, head-to-head or end-to-end. This is end, the other one is end-to-end overlap or head-to-head overlap. This one is produces sigma because end-to-end overlap. The two electrons are between the two nuclei. This is nucleus, this one is nucleus. The two electrons are at the center. Now, these types of overlap is SS overlap. SS overlap produces sigma. For example, hydrogen. Hydrogen atomic number 1, 1s1. Another hydrogen again, 1, which is 1s1. 1s1 means, look, S1. This one is the half field of S orbital. You know S maximum contains 2 electrons, but this is 1. Another S, 1s1 for hydrogen atom. 1, 1, overlap 2 electrons can be formed. SS always produces sigma bonds. The other one, or the second one, is SP overlap. SP means S spherical with dumbbell. This is the shape of S. S is spherical in shape. P is dumbbell. Now, S contains 1 electron. P contains again 1 electron. Between these two, overlaps can be formed. This is spherical. This one is dumbbell. Here, 2 electrons are present. This one is nucleus. Again, this is nucleus. This is S. This one is P. What types of overlap? SCP overlap. Students, this one, pi or sigma? Nice. This one is sigma. Why sigma? Because this is end-to-end. End-to-end is formed by S with S or S with P. Again, it's possible. Therefore, this one again, sigma. By the way, S orbital always produces sigma bonds. That means S with S, sigma. S with P, again, sigma. This is the second types of overlap. The third one is PP overlap. PP overlap. P, you know P. There are 3 types of P orbital: Px, Py, and Pz. Therefore, under PP, again classifying 3 types. 1, PP along nuclear axis. Along nuclear axis. PP along nuclear axis. Now, PP along nuclear axis means, you know first the shape of P. Look, this one is P orbital. This is, let's take Pz. Let's take this one is Py. Let's take this one is Px. Px, Py, Pz. Similarly, Pz, this is Py, This one is PZ. PX, sorry. PX. This is PY, PZ. 3 types of p orbitals. PX, PY, PZ or PZ. From the 3 types of PP, 3 types of overlap can be formed. 1, PX with PX. 2, PY with PY. 3, PZ with PZ. In this case, PX with PX, what types of overlap can be formed? From the 3 types of orbital, which one is parallel? By the way, there are 2 parallel. Look, PZ, this PZ with this PZ, these 2 are parallel. PY with PY is again parallel, but PX with PX is not parallel because along nuclear axis. Look, PX, PX along nuclear axis, along nuclear axis, which is this one. P with another P produces this one. PX along nuclear axis, PX along nuclear axis. This is can be formed. PP, therefore PP is can be formed. This PP is again end to end. Again, what types of bond can be formed? Sigma bonds. The other one, PY with PY or PZ with PZ. And finally, PY with PY. Look, PZ with PZ. PZ with PZ is produces this one. This one is PZ, this one is PZ. Look, in this case, when a line passing through the center, the lines touch the overlap. Touch the overlap, always sigma. But in this case, this is the center, this one is again the center. When the line is passing through the center, the overlaps are above and below the nuclear axis. These 2 are parallel, therefore pi bonds can be formed. Similarly, PY with PY. Look, PY with PY. This is PY. Another PY can be formed. The overlaps are here. When a line is passing through the center, the overlaps are above and below the nuclear axis. Therefore, PP forms sigma, yes, along nuclear axis. PP forms pi, yes, parallel or sideway. This is side to side, again this is side to side. Therefore, SS sigma forms, SP sigma bond can be formed. PP sigma bond and pi bonds are possible. PP sigma bond possible along nuclear axis. PP pi bond can be formed a parallel or side to side. Therefore, the 3 simple types of overlaps are SS, SP, and PP. The other point is hybridizations of orbitals. Hybridization is the mixing up of 2 or more different atomic orbitals of the same atom. The mixing up of 2 or more different atomic orbitals. What type of atomic orbital? S atomic orbital, P atomic orbital, D atomic orbital, S, P, and D different atomic orbital of the same atom is called hybridization. In valence bond theory, employs the concept of hybridization. In hybridization, the number of hybrid orbital depends on the number of atomic orbital. The number of hybrid orbital depends on the number of atomic orbital. There are 5 common types of hybrid orbitals: SP, SP2, SP3, SP3D, and SP3D2. Okay, in today's lesson, simply discuss about intermolecular forces, and also under intermolecular force, dipole-dipole force, London force, and hydrogen bonding. Also discuss about the chemical bonding theories, valence bond theory. The other point is metallic bonding, what I mean by metallic bonding, also the properties of metallic bonding. Students, in the next class, discuss about what I mean by hybridization in detail, what I mean by SP, SP2, SP3, SP3D, and SP3D. D2 ተማሪዎች በዛሬው ክላስ የተለያዩ ነገሮችን ለማየት ሞክረናል በቀጣይ ሃይብሪዳይዜሽን ላይ ሃይብሪዳይዜሽን ማለት ምንድነው አንዳንድ ኤግዛምፕሎችን ይዘን ለማየት እንሞክራለን ስለዚህ ዛሬ በተማራችሁት ላይ መጻፋችሁ ላይ መልቲፕል ቾይስ የሆኑ ጥያቄዎች አሉ እነሱን ጥያቄዎች ለማየት ሞክሩ በተለይ ቅድም ከነገርኳችሁ ጋር ከኬሚካል ቦንዲንግ ቲዮሪ ጋር ኤስኤስ ኤስፒ ፒፒ ጋር የሚገናኙ ጥያቄዎች አሉ መጻፋችሁ ላይ እሱን በደንብ አድርጋችሁ ሰርታችሁ ለቀጣይ ክላስ መገናኘት ይኖርብናል አብረን ስለነበርን አመሰግናለሁ በርቱ አጥኑ ቻው